Today we're going to work through the sound packet. And just as I talk through words, I just want you to fill in the blanks as we go. The first two pages focused on vocabulary. So our first word is sound. What is sound? Well, sound is a form of energy that travels as waves through matter. So we talked about that in class as sound moves in a compression wave. So it moves in and then out, kind of like a slinky. So just these definitions, I believe, are already on your paper. I just wanted to talk through them a little bit. A wave is just a change that carries energy from one place to another. So something's carrying energy, it's traveling through a wave. And so if you think of an ocean wave, it's carrying energy. If you think of a sound wave, it's carrying energy from one place to the other. A vibration, we talked about that too a little bit in class. So that's just moving back and forth very, very quickly. And you have to have a vibration in order to have sound. And we talked a little bit about the faster the vibration, the more frequent it's happening, and the higher the frequency, the higher the pitch. Crest we have not talked about yet, and that's just the high point of a wave. So if you draw the waves out, that's the top of the wave. While the trough is the opposite, and that's the low point of the wave. So those are two new terms. Okay, the next group of words is a wavelength, and that's just the distance between one crest, that's the top, or trough, to the next. So the length of one kind of, you think of it as like one loop to the next. A frequency is just the number of crests and troughs of a wave that pass over a certain amount of time. So how often there is a new wave forming. When you think of the wave and another wave and another wave and another wave, if they're close together, they're going to have a high frequency and a high pitch. If they're farther apart, they're going to have a low frequency and a low pitch. A medium is really just a fancy word for the matter in which a wave travels. So it could travel through gas, like air. It can travel through water. It can travel through solid. And the harder the surface, or the more dense the surface, the faster that sound is going to travel. We talked about pitch and volume in class also. Pitch is just our high or low. We talked about thinking of the Goldilocks and the Three Bears, right? Papa Bear's voice versus the baby bear's voice. And volume, you think about grabbing a remote. Volume is how loud or soft a sound is. Amplitude is a new word. That is just the size or intensity of the sound, it's wave vibration. That's that distance between the resting point and the crest or trough of a wave. So an amplitude would be like kind of the power that a sound has. So when you think of getting an amp out, when you think of maybe like a rock band, they have amps. So they're going to want to have more of an intense sound. Okay, so this page right here, those are just introducing our words, and now we're going to fill in our blanks. And this first page is just what is sound, okay? A sound is a form of energy that travels as waves through matter. Sound waves are invisible, and they carry energy from one place to another. All sounds are caused by vibrations. When we talk, our vocal cords vibrate. So right there, you can pause the video and then just make sure those words are filled in those blanks. Once you do that, you can move on to your picture. It says draw a picture to show how sound travels when someone plays the guitar. So you're going to want to show a guitar and a movement of a string. You can even kind of show those little dashes that you make to show kind of movement happening. And then that sound is traveling from that guitar through the air, then to the eardrum, and it moves to the eardrum we talked about all the parts of the ear all the way and sending signals to our brain that we hear the sound. So the vibration is happening in the guitar, traveling through the air to our ear. Okay, when you're ready, you're going to move to the next page, and that's how does sound travel? So sound travels in waves. They're really called compression waves. Remember, that was kind of like that slinky moving in and then out, and in and out, kind of coming together and then moving outward. The high point of a wave is called a crest, and the low point of a wave is called a trough. The distance between one crest or trough to the next is called the wavelength. So how long is the wave? A short wavelength is produced when the crests and troughs are close together, and a long wavelength is produced when the crests and troughs are far apart. So then the pictures here, you're going to just label the crests, which is the top part, and the troughs, which is the bottom section. So you'll have 3 crests that you'll show, or you can write the word crest and then kind of arrow to those 3 places. And then the troughs are the ones below. When you're ready, you're going to move to the next page, which is really all about a sound wave's frequency. And frequency just means how often something's occurring. Okay. So when you think of the bird in the book, it showed the bird's frequency or pitch, and it showed a wave that was very, very close together, all the parts of the waves. So that's going to have a very high pitch. And thinking of an animal that has a very low pitch, like maybe a lion's roar or something like that, they would be much farther apart. So up at the top, this is the number of crests or troughs, the top and the bottom, that pass by over a certain amount of time is the sound wave's frequency. So how often something occurs is its frequency. So how often it's going up and down and up and down and up and down. Crests and troughs that are close together have a high frequency, like we saw with that bird. It showed very, very high frequency. It moved up and down very close together. And crests and troughs that are spread apart have a low frequency. So high frequency, high pitch, like a baby bird or baby bear or a chihuahua. Crests and troughs that are spread apart will have a low frequency, low pitch, like Papa Bear, or a lion, or a big dog's bark. And then you want to label your high or closer together and your low or farther apart. You can even put a little note, high, and by high and low, high frequency, high pitch, low frequency, low pitch. So high pitch would be like the baby bird, or a mouse's squeak is a really good example. And a low would be like a Great Dane's bark. The next section, when you're ready, is all about how it travels through different mediums. How do sound waves travel through solids, liquids, and gases? So a medium is the matter through which sound waves travel. Sound waves travel at different speeds depending on the medium they're traveling through. Sound waves travel fastest through solids, and really the more solid or the more dense, the faster it's going to go. So if you have like iron or metal, that's going to move much faster than, say, wood. And they travel slowest through gases. So the more packed some surface is, the faster it's going to move through. So the water would be somewhere in the middle. Sound wave also move faster in warm mediums and slower in cold mediums. Okay, so that also can go along with the climate or even the temperature. Okay, and then it just says, give an example of how sound travels in the ocean. Well, you could draw a picture of dolphins communicating through sounds, or you can draw a picture of you underwater with a friend trying to talk. So sound does travel through water. That's a medium, just like it does through gas and solids. It just kind of has like a more distorted sort of sound. So you would give an example, and then you can even add to your picture if you would like. And when you're ready, you're going to move on. And then we're going to move to sound's pitch. Okay, what is a sound's pitch? Well, a pitch is how high or low a sound is. The pitch of a sound is determined by a sound wave's frequency, how often it's moving up and down. Sound waves with a high frequency will have a high pitch. Sound waves with a low frequency will have a low pitch. So there's a flute versus a drum. So a flute's going to have a very high pitch, while a drum's going to have a lower pitch. We're going to move into the idea of wavelength, frequency, and pitch, and how they're all related when you're ready. What is a wavelength? A wavelength is the distance between one crest or trough to the next. So remember, crest is the top part of a wave and the trough is the bottom part of the wave. So a short wavelength, they're going to be very close together. A long wavelength is going to be very spread apart. And a frequency is just the number of crests or troughs, how frequently it's occurring, of a wave that pass by over a certain amount of time. So how often the number of crests and troughs of a wave pass over a certain amount of time. Okay. And then how frequency and pitch are related. If a sound wave is a high frequency, it's have a high pitch. If a sound wave is a low frequency, it's going to have a low pitch. Okay, moving on to volume. Okay, some sounds are loud and some sounds are soft. A ticking clock has a soft sound, but a thunder has a loud sound. Volume is how loud or soft a sound is. Volume of a sound depends on how much energy the sound wave is carrying. So when you think of a remote, that's going to tell us how soft or loud the TV is going to be. So that's a volume, not pitch. Pitch is how high, low, while volume is how loud or how soft. That whole idea of energy, when you think about putting energy into something, it can sound very, very loud. So if you have a drum and you bang it really hard, you're giving it more energy. Therefore, it will have more of a loud sound. And then here just gave some examples, loud volume sounds you hear at school. Those are some examples there. You can come up with your own, just things that you hear at school. And then soft sounds. I don't know if you really could hear a clock, so I wouldn't put that one on there. But maybe the pencil sharpener, depending what kind of pencil sharpener that is. A mechanical one I would put on the other side. Book closing, whispering. Loud volumes you hear at school might be, people screaming at recess or, those kinds of things. To kind of come up with your own. If you'd like to change this to just put what are some loud sounds you hear daily, you can take away the at school and come up with some other things too. The next section is all about amplitude. So when you think of an amplitude, if you've ever heard of amps are what a lot of like rock stars or people that are in bands have. And that just helps the sound become more intense because they want it to be kind of loud and booming and like have a lot of energy connected to it. So that word amplitude has to do with kind of the intensity of a sound. So up at the top, it says the volume of a sound depends on the sound wave's amplitude. So the more energy you put into something, the louder or more intense it becomes. This is the size or intensity of a sound wave's vibration. So if you hit it harder, it's going to have a more powerful vibration. Amplitude is the distance between the resting point and the crest or trough of a wave. So if it shoots up really high, that's going to have a high amplitude. So if you think about a wave and then the top part goes way high and then comes down, that's going to have a higher or a more powerful amplitude. The louder sound has more amplitude and higher waves. So they're going to jump up higher, the wave is. A softer sound has less amplitude and shorter waves. So down here, just gives you that example of a lion's roar has more amplitude than a mouse's squeak. So if I were to draw the wave, my lion's roar would shoot higher in my wave and a mouse's squeak would not be very high at all. So the next section kind of shows you examples of that. So on the next page between volume and amplitude, if you look at the first one, that is a low volume. It's not shooting up really high from that kind of baseline, while the second one has a high volume. So you kind of see it has more peaks. It's kind of jumping higher and jumping below and jumping high and jumping below. So the waves of louder sounds have more energy, so they travel farther. The waves of softer sounds have less energy, so they don't travel as far. And then here's just again labeling those parts. So an amplitude is really that distance from that baseline to how tall it gets. That's the amplitude, how much it's kind of jumping up. And the crest is the top part of the wave, while the trough is the bottom part of the wave. And that is it. So we will have a sound energy quiz. I can even give you a little preview of it. Here's the little preview of the quiz when we come back. So they're going to have some true or false statements that go along with your notes. And then there's going to be a couple questions where you have to answer them, just talking about what you know about, frequency and volume and pitch and how all those combine together. So when we come back, you're going to hopefully have some good knowledge base to be able to do this quiz right here. And that little review book, I think, will be definitely helpful in that. So hopefully got it all down. It makes sense. And I will see you soon. Thanks.